Hey guys, welcome back. Hope you had a good weekend. So we're starting a new unit today, and I'm calling it Function Arithmetic, but I'm sort of giving an outline of the whole week. So this week we're going to be focusing on function operations. Today we're going to look at function notation briefly, and then really focus in on function arithmetic. And then later on we'll get into composition, and then all of the above with numbers substituted in. So function notation is basically where you use this notation, pronounced f of x, instead of y. So think of an algebra 1 type equation, y equals 5x plus 2. We would call that f of x equals 5x plus 2, or a function of x is 5x plus 2. So x is the independent variable, times 5 plus 2 is, things being done to that x. So functions are things being done. So this function of x is that it's being multiplied by 5 and added with 2. F of x does not mean f times x. So don't confuse that. F is the word function. So it's a function of x, which is 5x plus 2. Y equals 2x minus 3. You could also write f of x, but you could write it g of x equals 2x minus 3. And often when you do multiple functions at the same time, one will be called f of x, another will be called g of x. You might have one called h of x, stuff like that. So it's just a different way of writing the letter y. If you hear my dog in the background, please forgive me. Sorry about that. Okay, so that's function notation. Function arithmetic is adding, subtracting, multiplying, or dividing functions. And I realize that doesn't look very neat. My times is the dot, and the divide has dots in it too. So hopefully you can understand the difference there. And boy, could I spell arithmetic more incorrectly? Arithmetic. So there's two ways to write adding of functions. You can write f of x plus g of x, or it could be written f plus g of x, but those mean the same thing. Similarly, f of x minus g of x could be written f minus g of x. F of x times g of x could be written f times g of x. And then for divide, I know this is getting old, right? F of x. Usually the fraction bar is used for divide. Oops. Not necessarily, not always, but usually. Or it could be f over g of x. So everything we're going to do today, hold on. Excuse me, sorry about that. I turned away from the microphone. I hope it helped. Everything we're going to do today is adding, subtracting, multiplying, dividing, or maybe a combination of those things. And they could all be written in one of these two different notations. I'll tell you what I'm going to do to try and make this stand out a little better. Just to make a difference here, I'll use a slightly different shade of blue. So these can be written two different ways. And I've made sure that in this assignment it is written both ways. We're not worrying about composition or substituting in numbers, I don't think. Yeah. Okay, so as usual, I'll do the evens. Your assignment's going to be the odds. You'll need to show whatever work you can and check your answers, of course. And don't forget to grade your paper. So find g plus h, or h plus g of x. So we're being asked to add these two functions together. 2x plus 4 added to x cubed minus 5x. Sometimes you'll see these written in parentheses like that. So this is clearly one function. This is clearly the other. The plus sign is in between them. Not that you have to, but if that looks more clear to you, that's one way to do it. So then when you do this, it goes back to, honestly, pre-algebra, before Algebra 1 even. You learned about like terms and how you combine them. So 2x plus negative 5x. If you combine those, 2 and negative 5, you get negative 3x. The positive x cubed has no like term. I'm going to put that first. And the plus 4 has no like term. I'm going to put that last. And that's it. That's all there is to it. Once you understand what you're doing here, the skill level that you're employing is before Algebra 1. Let me check number 2. Wouldn't it be fun if I got it wrong? Talking about how easy it is. And it's right there. Okay, I made the wrong kind of answer key, but it works. No, nope. What am I doing? I just did number 2, not number 1. x cubed minus 3x plus 4. Yeah. Okay. Number 4 is also adding, but it's written the other way. Instead of, oops, sorry about that. Instead of g plus f of t, this time t instead of x, instead of being written that way, it's g of t plus f of t. But it's the same concept. We're going to add this function, 3t minus 3, to this function, 3t minus 4. Once again, it's adding like terms. 3t plus 3t, 6t, minus 3 plus minus 4, minus 7. And that is it. That should be the answer. Let me see if I can check it the right way this time. And there it is. You should have learned how to do this in Algebra 2. I know I teach this in Algebra 2. I might go a lot slower. I might do a lot more examples. This should be something, though, that you already know. So the next one is subtraction. We're asked to subtract the two functions. So g of x, 2x minus 2, take away f of x, 2x cubed plus 2. Now with subtraction, there is an issue with the negative in front of a parenthesis. It has to distribute into those parentheses. So this becomes 2x minus 2 minus 2x squared minus 2. So this negative goes here and it goes here. Now for like terms, I like to do the problem in order of the highest power. So negative 2x squared has no like term. I'm going to bring that down first. Man, I can't speak. Positive 2x becomes plus 2x. And then finally, minus 2 minus 2, when you combine that, is minus 4. So that was a subtraction problem. Remember to distribute this minus sign. And let's see if I got number 6 right. That looks right. Yep, that's the answer. Yep. Number 8. Also a subtraction problem. It's just written the other way, but it still means this take away that. X plus 4 comes first because h is first. Take away. G of x is second, so I'm going to go minus 3x plus 2 second. Again, distribute that negative sign, so you get x plus 4 plus 3, right? The minus minus turns to plus, minus 2. I'm sorry, that should be 3x. Can't forget that x right there. Now again, it's combining like terms. X plus 3x is 4x, and then positive 4 minus 2 is plus 2. So I've just subtracted those two functions. Where am I? 4x plus 2. 4x plus 2. So you're in a pre-calculus class. Manipulating functions like this, just doing basic work with functions, is a given. Everyone would be understood, knows how to do all of this stuff, kind of like the back of your hand. So if this is easy for you because you learned it last year, great. If this is new or challenging, you need to work on this. You need to pay attention, work hard on it, because it's expected you would just know how to do this, no problem. Okay, number 10 is multiply. Multiply usually is the one that takes the most work. We have to do h times g. So h is this one, 4x plus 2, times g, which is that one, so times x squared minus 3. To multiply binomials together like this, we have to revisit a good friend from algebra called the FOIL method. Hopefully you remember this. First, outside, inside, last. A little acronym to help you remember how to do this. So we multiply the first two terms together. 4x times x squared is 4x cubed. Then the outer two terms, 4x times negative 3 is negative 12x. Then the inner terms, 2 times x squared is going to be plus 2x squared. And last is 2 times negative 3, which is negative 6. So we did the multiplication, we did the whole FOIL method, and that's what we come up with. I would just bet when I scroll down, the answer is going to look like this, because polynomials are normally written in descending order, meaning the highest power first, then the next power, then the next power, which is technically a 1, and then the next power, which is technically a 0. So 3, 2, 1, 0. This ought to be the answer that we see when I scroll down to number 10. And There it is, 4x cubed, 2x squared, minus 12x minus 6. There it is. Number 12, also multiply g of n times h of n. Normally you don't put the dot there, you just use the parentheses next to each other. So g of n is 4n minus 2, h of n is n plus 1, and again we're going to FOIL. So this is 4n squared plus 4n minus 2n minus 2. Here we actually do have some like terms we can put together, so go ahead and do that. 4n squared plus 2n minus 2. And my check number 12, that should be it. 4n squared, where is it? Plus 2n minus 2, right there. Okay, so multiply is normally the most work. Divide is usually the least amount of work. So this is g of n divided by h of n. I take that back. Divide can sometimes be the most complicated one, but it's not going to be today. To do g of n divided by h of n, you draw, oops, let me go back to a pen. You draw a fraction bar. You put g of n on top. You don't even need parentheses. You put h of n on the bottom, and you're done. That's the answer. This is not going to simplify or work out. There is something called a domain restriction, which we'll talk about later in the course. We don't need to go over that right now. There it is. So we're not going to overcomplicate this. Number 16, this time it's written with the divide symbol, but same thing. Put down a fraction bar. F goes on top, 4n minus 2. G goes on the bottom, negative 4n minus 2. You cannot reduce this. Fractions, polynomial fractions do not reduce in parts. You need the same thing to reduce out of all of it. Actually, this one will reduce in a way. Let me talk about that. Let me check number 16 and see. Yeah, you see there's a different answer. So I guess this is worth discussing. You can't reduce the 2 with the 2 and the 4 with the 4. When there's multiple terms like this, the only way to reduce it is to reduce the same number out of every term. So what number can you divide out of every term? You can't divide a 4 out of every term, but you can divide a 2. So what you're going to do for this one, divide everything by 2. 4n divided by 2 is 2n. Minus 2 divided by 2 is minus 1. Minus 4n divided by 2 is minus 2n. Minus 2 divided by 2 is minus 1. So just like you reduce a fraction like, let's say 12 18ths, you divide these both by 6, right? And you get 2/3, divide them both by 6. We divided all of these by 2. And that's how you reduce a fairly complicated polynomial fraction like that. Maybe you already knew that. Sorry if you already did. But I have a feeling some people needed to see how to do that. Number 17. Now here we get into a combination. 4 multiplied by f, take away 4 multiplied by g. 4 multiplied by f, take away 4 multiplied by g. Not difficult math, just extra steps. Distribute this 4, you get 8t minus 12. Distribute this, treat it as a negative 4 and make it minus 4t squared plus 4t. So this negative distributes along with that negative. Two negatives make a positive there. And then combine like terms. Again, I start with the highest one first. There is no like term, so I'm going to write that first. Then we have 8t plus 4t, that's positive 12t. And then last is that minus 12. Check myself, that should be the right answer, number 18. Oh, too far. 4t, negative 4t plus 12t minus 12, there it is. And number 20, same idea, just multiple steps. 3 multiplied by g, so 4x plus 3, added to f, which is x squared minus 4. If I distribute this 3, I get 12x plus 9. Here, there's nothing to distribute. I guess you could say you distribute a plus sign, but you get plus x squared minus 4. I mean, it doesn't change anything. When you combine like terms, the only like terms are those, so I'm going to go ahead and write positive x squared first, This is a positive 12x, so plus 12x. Positive 9 minus 4 is positive 5. And that ought to be the answer to number 20. Oops, I was going to say nope. There it is, right there, looking good. Okay, so your assignment are the odds. They're very much like the evens that I did. Again, divide is going to be super easy. Multiply is going to take a little work. Adding and subtracting shouldn't be a problem. Sometimes with a subtracting, I'll get a student who forgets to distribute the negative sign, and that throws things off, so look out for that. But if you do have trouble, of course, contact me through email or comments, and I will help you as much as I possibly can.